Okay, so this is an extension video. So this is about the discriminant and the nature of the roots. So it is useful to us to be able to understand certain characteristics of a quadratic, maybe even before we get into graphing it, okay, and understand why it's happening. It's just going to help us. So I've just taken 3 separate examples of different kinds of quadratics. We're going to have a look and see what we can figure out. So this one here, I want to know the vertex. So, I can factor this guy and find the x-intercepts are going to be at 3, 0, minus 1, and 0. And I can use that to find the vertex. So the vertex is going to be at 1, minus 4. The y-intercept, I just set x equal to 0, so 0 minus 3. And then I go ahead and find the mirror point, which is at 2 minus 3. Some of you, if you're struggling to find the mirror point, remember to graph it first and then find the mirror points. This is minus 1, this is 3, so the vertex is at 1 minus 4. Okay, so the y-intercept is at 0, negative 3. So then I know the mirror point is going to be here at 2, negative 3. Okay, so then I can go ahead and graph it. So this is looking like a normal parabola. Okay, we're going to keep going and we're going to come back to this guy. Okay, so I'm going to factor this guy. So x minus 3, x minus 3. So my vertex is actually at the point 3, 0. Okay, that's where my vertex is. My y-intercept, I plug x equal to 0, so I get 0, 9. My x-intercept is at the same spot as my vertex, okay? The mirror point is at 6, 9. So if we look here, my vertex is at the point 3, 0, and my x-intercepts are also at the point 3, 0, okay? So this is a unique situation. Y-intercept is 0, 9, so then to get my mirror point, it's always the halfway point, so it's going to be here at 6, 9. Okay, so this is kind of a unique quadratic because the vertex is on the x-intercept. There's only one x-intercept. We're going to come back to it. So then we look at this guy. Okay, he does not factor nicely, so maybe let's change him to vertex form to make our life better. So we're going to complete the square. So I'm going to divide this by 2 and square it. So the number I need to complete my square is plus 1, and I need to also subtract 1 to make my equation stay the same. So there we go, completing the square. So now I know my vertex is at minus 1, 1. I know that my y-intercept is at 0, 2. My x-intercept, I would need to use my quadratic formula for this. And if I use my quadratic formula to do this, what happens is I get a negative underneath the radical. So I know that that means there are no real x-intercepts, okay? So then my mirror point is at negative 2, 2. Okay, so let's sketch this and let's look at what's happening here. So my vertex is at minus 1, 1. My y-intercept is at 0, 2. So my mirror point is at minus 2, 2. So if you'll notice, this quadratic has been shifted up and it is not crossing the x-intercept, which is what we would have expected. So how many roots do I have over here? I have 2 roots. And by roots, I mean that's another word for x-intercept. So I have 2. How many roots do I have here? 1. And how many roots do I have here? I have none. So basically, do I have to do all this work to figure out that I have 2 roots, 1 root, and no root? And the answer is no. I just need to figure out the discriminant. So the discriminant is the part underneath the quadratic formula, underneath the radical. This part right here is going to tell me all the secrets, okay? So when I say the word discriminant, I'm asking you, what is b squared minus 4ac? So if I do it for this one, I get 16. Sure, that doesn't really mean much to us, okay? For this one here, I get 0, okay? And if you think about the quadratic formula, minus b plus or minus 0 over 2a. Well, if this part's 0, I don't have 2 roots because I don't get the plus or minus part. So that's why this only makes 1 root, okay? And b squared minus 4ac, if I do it for this question, I get negative 4. So it makes sense to me that I would have no roots here because I have a negative number underneath and I cannot take the square root of a negative number. So our final conclusion, if this is bigger than 0, okay, so if the discriminant is bigger than 0, then we have, oh sorry, it's the order is different on your page, so I'll go in the order. So if b squared minus 4ac is less than 0, we call these roots imaginary roots. You have imaginary roots and you have no x-intercepts, okay? So imaginary numbers come from when you have a negative underneath the square root. So that's what happens in this situation. So then we'll go here. If I have this bigger than 0, then it's like a normal situation. So I have real, so these roots are real, they're not imaginary, they're positive underneath the radical, and they are distinct. And what distinct means is they're different. So I have a 1 at -1 and 1 at 3, okay? Then if my discriminant equals 0, then my roots are still real, okay? I don't have anything underneath the radical, so I still have like x equals, there should be an x, okay? So they're real, but they're equal, okay? Because I have 2 roots, they're both at 3, okay? So this is the discriminant and the nature of the roots. So when you're classifying your roots, if I ask you to classify the roots, all you need to do is figure out what the b squared minus 4ac is. You don't do all of this, just need to figure out what b squared minus 4ac. If you get a negative number, you know you have imaginary roots. If you do b squared minus 4ac and you get a positive number, you know that they are real and distinct. And if you do b squared minus 4ac and you get 0, you know they are real and equal.